Last video of the section, let's do some homework problems together from the book. So let A of x represent the area bounded by the graph and the horizontal axis and the vertical lines 0 and t. That might not make too much sense, but let's keep reading for now. Evaluate A of x for x equals these values. So all at once is A of 1, A of 2, A of 3, A of 4, and A of 5. Now, what do these represent? A of 1 is the area between the graph and the horizontal axis and the vertical lines at t equals 0 and t equals 1. So the graph is, let's draw this over here, right? The graph is right here between 0 and 1. So these are the vertical lines. And the x-axis. So A of 1 is just this area right here. Right? A of 1, just this area, just this box. It's just 1. A of 2 is the area between these. Now this area is more complicated. Right? So now we need this area. Well, we'll just add the boxes together, right? So this box is 1. This box is 1. And we need this triangle, which is 1/2. So it's 2.5. And so on. Now A of 3 is going to add this area to our previous area, signed area. Or actually, no, it doesn't specify. It's all positive anyway. That's going to add 2 more. Right, this rectangle is an area of 2. So now our area is 4.5. And then again, we're going to add another 1.5 because now we're adding more area. We're going to get 6. Again, this whole thing is 1.5, just like it was before. Area of 5 just adds another box to the previous area. It's going to be 7. A of 5 equals 7 because if we look at this whole area, it adds up to 7. That's what this first question is really having you go for, but it's worded in a kind of a confusing way, so that's why I wanted to do it on the video. All right, next one. You and a friend start off at noon and walk in the same direction along the same path with the rates shown. Again, this is showing your velocity. It is not showing your position. This is a rate. Question A wants to know who's walking faster at 2 p.m. Well, at 2 p.m., that's where we are. Who's walking faster? Oh, we're both walking at the same speed. Okay. Walking at the same speed. Who's further ahead? That's a little bit more complicated, but not actually that complicated. Because the area under the rate is the total change. So the area under my graph is how far I've gone. The area under my friend's graph is how far they've gone. So who's gone further? I have. My area is bigger. I'm ahead. Again, because of bigger area. The area under a rate is the total change. So the area under velocity is your displacement. I've gone further. B is very similar. Who's walking faster at 3 p.m.? Well, at 3 p.m., my friend's walking faster. Okay. Friend is faster. Who's ahead? That's a little harder. There's a couple of ways of doing it. You can either look at, okay, whose area is bigger and make an educated guess. Or let's make this a little bit cooler, talking about something a little bit more complicated. How much further was I ahead at 2 p.m., right? 2 p.m. is when they started going faster than I did. How much further was I ahead? Well, I had gone this far, and they had gone this far. What's the difference? The difference is this much. This black area is how far ahead I am. How ahead I was at 2 p.m. And now, between 2 and 3, this, hold on, let me be a little bit more precise. This is how much distance my friend gained. Nope, not fried. Not quite. Friend gained this distance. So who's ahead now? Well, the distance they gained is smaller than the distance I was ahead, right? I'm still faster. They caught up a little bit, but I'm still ahead. You can either compare the total areas or compare the distances, the differences. When will you and your friends be together? When I stop and wait for them. I'm essentially when our, areas are the same. The areas are the same is the simplest answer. It's not asking for a time because we can't find the time. That's when we will have gone the same distance from when we started. And if we've each gone the same distance and we're, again, walking on the same path, then we'll be together. That's what it's looking for here. Last problem. It wants us to represent the area of each bounded region as a definite integral, and then use geometry to find the value of it. So we're going to need a picture here. And you could draw the picture by hand. I also kind of want to show you how you could use Desmos to help you draw this picture. So once the region bounded by 2x, the x-axis is y equals 0. The line x equals 1 and x equals 3. What is the area that's bounded between all 4 of these curves? It's this area in the middle. Okay. That's what we've got going on here. How can we find this area? So a couple of ways that you can do it. Again, it kind of is probably easier to copy it down to your paper. Staring at this like so is not going to be very useful. But if you copy it down to your paper, it gets a little easier to work with. So we copied it down to our paper. Then what we want, right? This area in the middle. We're looking for this yellow area, which is, right, this triangle plus this green square is the area. So green square, that's going from 1 to 3. It has a base of 2. And the height of 2. Yellow triangle also has a base of 2. And the height now is 4. The height is going from 2 up to 6. So they're the same areas, actually. So this integral, the area, right? It says write it as a definite integral and then use geometry. This area equals the integral starting from 1, going to when x is 3, of our function with respect to x. And we can find that definite integral using geometry. That's going to be the 4 green units plus, I'm not going to write it in yellow. You're not going to be able to see it on the white. 1/2 base times height from the yellow. Still color code it. That's just going to be 4 plus 4. The area is 8 units squared. Technically, it just wants the value of the definite integral, though. So we'll just say the value is 8. If you're ever unsure about what I'm looking for with units here, just send me a question. Ask me. That's what we've got going on here. And I think that's all I wanted to do for this video. So let me know if you have any questions. Welcome to Chapter 3. Welcome to integrals. And have a good rest of your day. Bye-bye.